Welcome back to the Information Week news desk. We are live in Las Vegas, bringing you the latest and greatest from Interop ITX. I'm Lenny Liebmann, your host today, and our next guest is Director of Sales Engineering for Cylance. It's Rich Thompson. Rich, it's good to see you.
Thank you, welcome.
Your security company, I can't help it. First question I have to ask you is about WannaCry, especially when it comes to endpoint security. So I'm going to just give you an opportunity to make any comment you want to about why your organization are exposed or what this might highlight about other endpoint exposures more generally.
Yeah, actually WannaCry is interesting from the fact that it highlights one of the biggest problems in security today, which is the unknown, right? That the attackers have the upper hand to be able to create unknown, to be able to morph or mutate into an unknown binary base that is going to cause a problem for traditional approaches that use signatures or have to know the bad before. It highlights the biggest problem, which is the problem of identification. Being able to identify before an event happens and be able to do something about it.
So why don't you talk a little bit about how you guys address this notion of not depending on signatures so that we can more nimbly respond to new threats?
Sure, so our approach has been exactly that, is how do we identify unknown? And our approach to that was to not use what everybody else had done, which is signatures and heuristics and behavioral and things of that nature. We don't want to watch what happens after the badness occurs or have a patient zero or a sacrificial lamb that occurs. We utilized artificial intelligence, machine learning, predictive modeling in order to identify files up front. And we have to do that by learning off bad and learning off good, using artificial intelligence and constructs within that in order to get enough data to make accurate predictions at basically the bit byte layer of a file. The DNA of a file, if you will, and there's a lot of correlations to that. Taking not just subsets of that, this feature, that feature automatically means it bad, is that the combination of millions of features can tell us a lot about a file, and the only way to really gain access to that is through machine learning. To be able to use artificial intelligence model, then make an accurate prediction. If you can fix that problem of identification, then you can take action. And so now in our approach with the math models, we're able to make an identification of bad or good within milliseconds against a static binary, which allows us to stop execution before it occurs. Never let the binary get into memory space and begin to load, because we can make the identification up front.
So I think what you're saying before too is that even if you try to identify these binaries by overly specific attributes or sequences, that's still like a signature, sort of a sub-signature. So there's something about the correlation, there's a style of people who write these things that we can discern through machine learning, because there have to be some commonalities in how these guys develop stuff.
Yeah, well, the good part about it is they're working within a known universe. That known universe is the binary base to the application, or to the OS, or to the structure there. So PE based in Intel or Wintel based systems, and Mac Ho and Macintosh systems. And because they have to operate within those worlds in order to execute and to be able to run, it allows us to learn that. And the problem always in the industry has been exposure. Can we expose enough feature sets to learn against? And in a traditional signature-based approach, you're looking for this feature plus that feature, maybe this one over here. And when the attacker changes one or two of those, it's game over. Whereas when you're looking at the bit binary level of a file, and you're able to do that over millions of attributes of the file, and then learn what each little sequence, not just the sequence, each little bit and byte may mean, what it could do, allows us to identify that bad even if the attacker attempts to change it.
It's very analogous to even what's going on in healthcare, right? Where they're trying to, it's very similar to genome sequencing.
My brother and sister-in-law are endocrinologists, and they work in a lab, and they sequence DNA on a regular basis, and you change two features, you get two features, it says you're going to have diabetes. You throw three more, it has nothing to do with diabetes anymore. You're going to be 7 feet tall, but those two features are present, and in a signature it'd say, well, you're getting diabetes. That's not exactly the case.
So you guys, are you the only guys doing this? Are there other sort of security vendors who are talking about using AI to go signatureless in terms of recognizing binaries? Anything in particular that's distinguishing you guys, either in terms of how you do it, or perhaps just as important, how you allow me to deploy your technology in my organization, which is another challenge?
Yeah, so we were the leaders and the first to really get out there and do this on a wide scale. Artificial intelligence has been around for years in many different environments. We were the first to apply that to this method of prediction, and to make an accurate prediction before execution. Now, that was about 5 years ago, just a little less than 5 years ago, and now the industry is starting to change, right? That's part of making big waves and changes, then people start to change their approach. we've seen a couple of other vendors start into that space. And we'll start to make inroads into doing better for their customers on protection. We've had that for about 5 years now, protecting our customers up front. It gives us ability, like when going back to WannaCry, our math models were able to predict and kill those files well before the attacker coded it, and we're able to stop WannaCry going back as far as almost 2 years on 2-year-old math models.
Okay.
So a significant level of protection up front, which means without having to take updates or do cloud lookups, or do reputation searches or things like that, we're able to stop a binary that's a 0-day.
Right.
So that on Friday, there were many customers of ours that was not an event any longer, right? Where unfortunately people were affected by it. And those approaches is what really kind of broke down there.
And I'm assuming that because of the way AI works, over the course of time, your algorithms or identification mechanisms get stronger incrementally and continuously.
Yeah, they can get smarter. A couple different reasons why is advancements in the math and advancements in being able to extract data. And that in constant learning allows us to get smarter over time. The good news is the older models don't particularly decay.
Right.
So I've got customers who are on older versions of models who don't feel the need to update because they're still well in their acceptable protection range, which is well above 99%.
And do you see this as having not only security implications, but can it help me with my compliance posture too, to implement this kind of technology?
It can in a sense. We certainly don't go to market and go at that realm, but when you're doing identification in a big way and you're able to identify and stop things from happening, all the downstream effects that we've put into place with our defense in depth, and whether that's compliance and auditing, whether that's incident response and EDR, a lot of those job functions tend to be reduced, right? The volume of load, let's say caseload on an incident responder tends to go down because we're stopping the execution. If we stop the execution, then all the ramifications that go downstream no longer have an effect, right? And so we see a dramatic reduction in that workflow by preventing up front.
Yeah, no, I think it's an important point that sometimes people tend to look at endpoint in an isolated way instead of realizing that you even start to put your mainframe at risk, right? The mainframe is an inherently secure platform. Nobody's getting in there. The way they're getting in there is they're getting in somewhere else and they're spoofing credentials, and then they can get into your more secure systems. Correct,
and so you'll see development over time. So the math and the way that we've addressed the AI space and be able to make identification can be extended into many other worlds.
Right.
And just like we've seen AI used in other industries. I mean, we all use it today on our phones in probably 6 or 7 different ways that we're unaware of. It will start to trickle out and we will be able to address other problems as we continue to develop.
Looking forward to that. I'm sure we all need that to happen. That is Rich Thompson from Cylance. Stick around, we got more news coming up from the news desk after this.